Welcome to an introduction to blockchain indexing, a quick primer brought to you by SubQuery. In this module, we're going to cover the following points. What is indexing? What is blockchain? And then combine the two concepts to understand what is blockchain indexing. We'll then look at blockchain and indexing architecture, and then talk about SubQuery, and then what's coming up next. The word indexing in computer science usually involves getting a database table organized in such a way that you can search for information very quickly. To be more exact, database tables are created to point to the location of folders, files, and records. Depending on the purpose, indexing identifies the location of resources based on file names, key data fields in a database record, or text within a file, for instance. It's exactly like how an index works at the back of a book. It allows you to jump straight to the information you are interested in very quickly. And perhaps the most famous example of indexing is Google. Google has spiders or bots that crawl the web and grab all the information available and stores it in a gigantic database. It then indexes this data, allowing you to search, for example, who is the tallest person in the world, scanning 84 million results in just over half a second. This is the power of indexing data. Let's now take a look at what is blockchain. There are lots of definitions out there, such as it's a secure database shared across a network of participants where up-to-date information is available to all participants at the same time. This is from McKinsey. Wikipedia defines it as a distributed ledger with a growing list of records or blocks that are securely linked together via cryptographic hashes. A system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system from Euro money. And a shared immutable ledger for recording transactions, tracking assets, and building trust from IBM. There's a common theme here that it is essentially a database with information stored in groups or blocks and then linked or chained together. And because it's a database, the applications are limitless. It can be used to record transactions, track assets, or even write a message to a special someone. Now, the blockchain database contains a lot of information, and searching for information is not particularly fast. In fact, you have to search through each block one at a time, making it incredibly slow. Modern complex applications need a great deal of volume of data, and they need it fast. But it takes time to query the data from a blockchain using the default API provided. In addition to this, the amount of data on the blockchain is constantly growing. The more blockchain-based dApps we have, the more information they store, and the bigger the blockchain grows. And the final point is that it is also hard to query data across different chains in this multi-chain world. This is where indexing comes in. Blockchain indexing is essentially the process of extracting all the information on a blockchain and then storing it in a traditional database, a relational database to be exact, such as Postgres or MySQL. Once this is done, all the traditional indexing techniques are applied, and this information can then be searched very, very quickly. But in order to understand more about blockchain indexing though, we need to know a little bit about blockchain architecture. So we know that a blockchain is a database, but it exists in a network. Individuals around the world run code on their computer and talk to other computers. These are called nodes, and all these nodes store the same copy of this blockchain database. This is very similar to how the internet works, and we call this a peer-to-peer network. This type of network has the following advantages. Because there are multiple copies of the blockchain database, It's very hard to destroy or to take down. The data is distributed, and there's no central authority that controls the network. Therefore, it is decentralized. The system was also designed to be transparent because all transactions on a public blockchain are viewable to anyone with an internet connection. It's immutable. Once the data is recorded on a blockchain, it cannot be removed or edited. And it's also secure due to the network structure and the high level of cryptography involved. And the result of all these properties creates this trust that people believe in, which has then created value. All blockchain indexing works in a similar manner actually. There's a piece of software that extracts all the data from the blockchain node and then stores it in a regular database, such as Postgres or MySQL as mentioned. This data is then indexed, and then an API layer is often provided for anyone on the internet to use to search for blockchain data. This process seems simple enough, so why not build your own indexer? In fact, many companies do build their own indexers. They often dedicate an entire team to do so. However, this development can be costly, utilizing developer resources whose time could be spent developing the company's killer app. It's also hard to develop. Specialist knowledge is required and constant maintenance and updates are needed to keep up with any changes. And finally, why reinvent the wheel when there are existing indexing tools out there that specialize in blockchain indexing such as SubQuery? SubQuery is an open source, flexible and powerful multi-chain indexer. It allows you to index, transform and query data from various blockchains that we support. And our main focus is to make it fast, flexible, open and universal. There are many benefits of using SubQuery. First of all, it's open source, as previously mentioned, with multi-chain support. We have an experienced team solely focused on building our indexing technology. It is also trusted by many organizations that we have since created powerful partnerships with, and we're constantly expanding into new ecosystems. We have advanced features that allow flexibility and provide a high reliable service. Look out for more lessons on tutorials focusing on use cases in the areas of DeFi and wallets, NFTs, and also governance and DAOs.